Hey, what is up, guys? In this video, I'm going to explain what is Mutex, what is the concept, why we need Mutex, and all those things. Okay, so before going into the technical explanation of Mutex, I would like to explain the Mutex with some real world analogy. I have drew a sample diagram, a sample flow diagram to understand the Mutex. Let's say you are in a mall, okay, and you want to access the restroom, and let's say there is only one restroom in the entire mall, okay. uh, okay, some other people also coming and trying to access the restroom, but we have only one restroom, okay. Let's say when the person A goes into the restroom and didn't lock the door, and also at the same time the person 2 tries to get into the restroom, and person 3 and person 4 and so on, because nobody that gone before hasn't locked the door. And you think this in your real world analogy, this will become very nasty and very funny, right? So to avoid these kind of scenarios, we have lock, we have door. That's why we have door, and that's why we have lock. Okay, when the person A goes in, first they will close the door and acquire the lock. And when they're done with the thing, they will come out and they will unlock the door. And the next person can go in and they will do the same thing. They will lock, and when they come out, when they go in, they will lock, and when they come out, they will unlock and allow the next person to go in. So this goes on. This is fine. Okay. Now we see what's the purpose of lock. Okay, because we have only one bathroom, and so many people trying to access the single bathroom, the only one bathroom. Let's consider this in a programmatical way, or in a programming world. Let's say we have only one value and multiple threads or multiple writers or readers trying to access the same data at the same time. What will happen if we didn't do lock? If multiple writers trying to write the same data at the same time, it will become corrupted, because we know, let's say the writer one doing their write, and they didn't complete the write operation, okay, and at the same time the writer 2 comes in, they also want to access the data, and it will become the incomplete write operation, or the data or the corrupted data. Anyway, I would like to explain this with some real example. Here we have, let's say we have a log file, okay, and here we want to write these 3 lines, okay, and here we have writer 1, writer 2, and writer 3, okay. The writer 1 comes in and they want to write this line, writer 2 comes in, they want to write this line, and writer 3 comes in, they want to write the third line, and so on. Okay, this is good. So this is good when this is good when we have only one writer, okay, when we have only one writer at a time. But when we have 3 writers trying to access the log file at the same time, then there are chances it will become chaotic. Let's say when the writer 1 writing the data 1, 2, and 3, 4, and so on, at the same time the writer 2 comes in, they also want to write their data 11, 12, and 13, and 14. So what will happen is, before the writer 1 completes their write operation, what will happen? 11, 12, 13, 14, and again there could be a chances it will become a 6, 7, 8, 9, and so on. It will go. Okay. So here we can see the data that we intended, that we actually want to write, is not correctly placed in the log file because of too many writers trying to write the data at the same time. And this will happen even for the third writer. Let's say the writer 1 and also the writer 2 didn't complete their operation. At the same time, the writer 3 also comes in. Let's say they want to write their own data, and it will become like this. Okay, and 18, 19, and 20. It will go like this. Okay. In order to add more chaos, what will happen is, let's say some reader wants to view all the data written by these writers, and let's say the same reader comes at the same time, while these 3 writers are trying to write the data at the same time. Now we have 3 writers, let's say one reader. What will happen? The data is already corrupted because of so many writers trying to write the data at the same time. So this is the final data that the reader will see, and this is, in this way we can see the data is actually corrupted, and the data overall, this is not good, right? So this is the overall purpose of why we need lock to when we do the read operation and also the write operation. Okay, when we do the lock operation, what will happen is, let's say the writer 1 comes in first, okay, and they lock, okay, until the write operation completed by the writer 1, it will not let the writer 2 or writer 3 or reader 1 or reader 2 to access the data. Same for writer 2. Okay, once the writer 1 completes the write operation, then second the writer 2 comes in, and the writer 2 writing the data at the same time, it will not allow the writer 3 to write the data. That's why we have lock. When we acquire the lock, it will not other resource or other person to read or write the data at the same time, or until the previous operation gets completed. This is the overall logic of it. Okay, fine. Mutual exclusion is a synchronization primitive used in concurrent programming to prevent multiple threads from accessing the shared resource at the same time. Okay, so let's compare this with our log file example. Here we have one log file which is shared with multiple readers and multiple writers, and all trying to access the read the log file or write the log file at the same time. So we see why this will become chaotic. In order to prevent these kind of scenarios, we have Mutex. So what actually Mutex does is it acquires the log. It allows only one reader or only one writer to do the operation at a time, so that the next read operation or write operation has to wait before the previous operation gets completed. Okay, that's the overall logic of it. At any given time, there can be only one resource can read or write the data. Okay, that's the overall logic of it. So what are the actual benefits of it? Prevents race condition. The race condition. So what will happen in race condition that we already seen in this example? The log file will become chaotic, and the data will get corrupted. The data that it gets written to will become corrupted. So many things will happen. Okay, so that's the example. I will upload this, and you can go through these examples, and also you can go through this flow diagram. Okay, that's it, I think. Coming to the code, coming to the coding part, the mutex is located in the standard, and also in the standard package from the sync package. Okay. Uh, okay. To use mutex, we will let's say we are going to take an example of count. The count is, let's say, this count will get written will get read by multiple users, and also will get updated by multiple users. Okay, let's say we have count and mutex 0. Let's say initial count is 0, and let's say the user 1 comes in and they want to update the data. They want to increase the count value by, let's say, 100. In order to do it, what we have to do first, we have to acquire the log in the concurrent programming language. Else multiple let's say the user 1 comes in, user 2 comes in, user 3 comes in at the same time, then all these users will try to update the count data at the same time. In order to prevent the data corruption and also the race conditions, we have to first acquire the log. So to acquire the log, we will use the log method and unwrap. Okay, and we will have the mutable count changer. Here we have the mutex code, which is also mutable, which means here we are going to update the count value, which is count changer. What's the spelling step I'm doing? Increase it by, let's say, 100. Okay. Here we have acquired the log. Okay, we haven't released the log yet. Okay, so we will print it. First we will print the value, and also we will print the log status of the value wrapped in the mutex. Print count. We have to use this, and let's run it. Okay, so here we have the updated value, which is 100, and here we can see the user 1 that came in, who has acquired the log first, hasn't released the log yet. So when the user 2 comes in trying to do the operation at the same time, they cannot do it because it's already logged. In order to let the second user to update the data, we have to release the log so that the second user or third user can read the data or write the data. Okay. Okay, this is the basic example how you can add wrap value within the mutex, and you can update the value, and also you can here we can read and write the value, the basic syntax of that we have seen. Okay. Okay, let's say the user 1 is already doing the write operation or read operation, whatever it is, and at the same time the user 2 also comes in. Okay, so in programming, when it comes to the programming syntax of it, we have to make sure the log that was already acquired by some other threads or some other user should have been released. Here we have acquired the log. Here we have acquired the log. This is let's say this is done by user 1. And the user 2 also comes in, and they want to do their read or write operation at the same time. And the user 3 comes in, they want to do their write operation. Okay. And when user 2 comes in or user 3 comes in, let's say they didn't check whether the value or the resource is already held by some other threads or some other user, and they also trying to acquire the log to do their read or write operation. Let's say we have count changer to and count log. Here what will happen is, first I will run the program. Here we can see the program hasn't completed, because what happens here is the user 1 is already holding the log, okay, and user 2 is also trying to hold the log. But what happens is, it actually none of them are letting it go further. Okay, in the sense, let's say I have a water jug here. Okay, let's say the user 1 trying to hold the water jug, and also the user 1 is already holding the log. Okay, and user 2 also comes in without knowing the user 1 is already holding the log. The user 2 also trying to take the jug or drink water from it. Okay, then what happens is they will try to pull each other, and they will wait indefinitely to acquire the log, to do their operation. So this is a deadlock. Okay, this is the deadlock scenario, and in order to avoid these kind of scenarios, what we can do is, just a second. Yeah, what we can do is, we can check whether the lock is already we can check whether the lock is already holded by some other user. Okay, count changer count try lock and match count changer. Okay, if the resource has been locked by any other resource or by user, then we can update or read the value. If it already acquired, then we will get error, and we can print it something like this: count lock poisoned or unable to acquire lock, count lock, something like this. Okay, okay, this is done. First we will create the syntax, acquire the lock, occurs, this is done. Replace the lock, deadlock of items. Okay, non-block, this is also done. Okay, I think that's it for the basics of Mutex. This is the very basic concept of Mutex, why we need Mutex, how we can do the basic read and write operations of it. In production applications, this will get very complex. Okay, and in this example, overall, you can think this main function is single threaded, why we need Mutex here. This is just single threaded, why we need Mutex here. This is just, I have just showed you the basic example of it. Okay, we will improve it by using the Tokyo or threads, using the multi-threaded programming, and we will do some concurrent operations with the data. Okay, that I will try to explain in the next video. Thank you.